Hi, I'm Brian Gilson. I'm head of vertical market sales here with Ordr, and I'm here to talk about our cyber asset attack surface management product that we call Ordr SCE, or Systems Control Engine. Before we get started, I just wanted to give you a quick overview of who Ordr is as a company, where we came from. So first off, we were founded by an amazing team of engineers and executives from some of the leading network and security companies on the planet: Cisco, Aruba, the folks that made the underlying infrastructure that we use today. And so this intelligence about the network, about the devices that connect, really forms the heart of the platform that we've built. We've been in the business for about 7 years now, developing the product. We spent a long time building the infrastructure in place before really going to market aggressively. Since then, we've had a huge amount of success across some of the most notable companies in healthcare, manufacturing, financial services, and education markets. We've got great funding from some of the leading venture capital firms in the Valley, and we're a representative vendor in the Gartner OT Security Market Guide, and we've been identified as a leader in the KLAS Research Healthcare IoT Security Guide for multiple years running. So how does Ordr fit into cyber asset attack surface management? And what is what they call CASM? Well, it's beautiful, right? CASM says exactly what it is. There are 3 pieces to it. First, there's cyber asset, right? And this is, if you're protecting your organization, you need to know what are the assets that are connected to your network. And that means all connected devices. Not just OT, not just IoT, not just your medical devices, but everything across all of your business silos. They have to be managed. Some of them have ADR, some of them have network security on them. Some of them are rogue devices that your users are just plugging into the network because they can. But you need to see all of those cyber assets to know what your risks are. And that really goes into the next piece, attack surface. What does that mean? That's like, what are the vulnerabilities that these attackers are going to use, and where are they going to attack to penetrate your network? So that means identifying vulnerable devices, which ones have active exploits, which of them are doing things that they've never done before that may be an indicator of a compromise that your existing security tooling isn't even identifying. And then finally, management, right? You don't just need another system that's giving you alerts and alarms and overwhelming your help desk with more things they need to do. You need to be able to take action very quickly to remediate systems which are being exploited. You need to be able to orchestrate with the existing workflows in your organization to put things through the right processes that you've already built. But ultimately, you also need tools to proactively protect your organization so that your systems cannot be exploited in the future. And that's really at the heart of how we interpret the CASM space and the functionality, which is really defined by Gartner. Now, this maps almost perfectly to how Ordr views the world. We call the methodology See, Know, Secure, because this really maps to the sort of the value that customers get over time through using our product. See is very simple. See every connected asset, not just that it exists, but understand what's its make, what's its model, what's its serial number, what's its business purpose, but also how is it connecting to the network? What a device is and what it does ultimately go hand in hand. Is the device using an unexpected network protocol? Is it a rogue FTP or web server that you're not aware of? Do you have operational technology or medical devices that are connected to your guest network? All of these things need to be understood in order to really understand what that attack surface is. And we're able to identify each of those. The next is know. Now that you know what these devices are, which ones are vulnerable? We can correlate between what the device make, model, serial number is, and what CVEs or known vulnerabilities have been reported to various databases out in the world. We're able to look at the traffic and understand the exploits that may be currently ongoing in your network. We can look at the connections that are being made outside of your network and correlate those with things like known command and control sites or ransomware sites or even Bitcoin mining or social sites. And then finally, because we know what the devices are, we're able to group them together into known device groups and say, all of the devices of the same type, when they're a fixed function device, maybe it's an MRI in a healthcare organization, maybe it's a security camera, maybe it's a badge reader, all of those devices should do the same thing. A badge reader is not going to wake up and decide to surf Facebook one morning. But if it does, you know you have a problem. And so we're able to look at this anomalous behavior by identifying traffic that's unusual and hasn't been seen in peer devices. And that's a key part of this know component of the attack surface management. And then finally, you have to be able to secure things, right? So again, how do you get proactive? How do you get in front of these attacks? Segmentation has been used for a long time as a means of separating out important devices from maybe less important devices, putting devices of a certain type together with other devices of its type. But the problem is, you have to know what the devices are in order to create those smart segments. Network access control, also frequently used to protect devices. Again, in order to create network access control policies, you need to know what the devices are and what they're doing. So when you build those policies around them, you're able to now ensure that those policies allow the devices to do what they need to do, but ideally nothing else. That has been called zero trust security. It's been called least privilege security. It's been called microsegmentation. But ultimately, if you don't know what the devices are, you don't know what they're doing, you're not going to be able to secure them using these advanced network tools the way you need to. But of course, there's also very simple tools like, this device is being exploited. I need to get it off the network. You need to be able to click a button right there and have that blocked at the switch port. Maybe it's a device you need to run vulnerability analysis on. You want to put it into a quarantine VLAN. You need to have a tool right there that can migrate that device to a VLAN and ultimately allow you to do the incident response and analysis actions that your team requires. So we're able to provide all of those tools via integrations with a wide variety of systems, tools, operational systems that are already on most networks. Now, the business value that you get from these, that's great, right? That's what the things do. But the value that you get from this is often subtle, but very, very important. Number one, just having an automated inventory in real time of your entire device framework is a huge time savings. You no longer need to have people walking around taking inventory. You no longer have to be spending time in your CMDB wondering which devices are still connected and which ones aren't. From a vulnerability analysis standpoint, being able to know what those vulnerabilities are, but then tie it back to the specific device allows you to cut the response time from determination that there's an attack underway to your time to do something about it, sometimes from hours to minutes. Because just knowing that an IP address is communicating over a certain port at a certain protocol, that's important. But what is that device? Is it a business critical device? Is it something that's a caregiving device in a hospital, or is it a security camera in a back parking lot that can be removed? You need to know that information very quickly. What types of remediation can take place? Do you need to patch that system? Do you need to take it offline? Do you need to put in a compensating control? All of those decisions can be made when you know who's the business owner, what is the business type, and track it back to the device. So again, cutting that response time down for exploits, absolutely massive value. And then finally, on the secure side, being able to take all of the information that Ordr can provide about devices and device context, putting them into your infrastructure so now your network administrators are no longer struggling to identify which IP address correlates to which business unit, which locations contain which devices, what things are to create their NAC. We provide all of that automatically through APIs into those systems, allowing your administrators to reduce the time they're spending on this drudge work and spend more time doing the important tasks of network architecture, keeping things up to speed and up to date, removing end-of-life equipment, and so forth. So in today's times of having very difficult hiring, it's very hard to find and keep personnel, being able to keep your people, to be efficient, and working on interesting things, again, absolutely critical. So being able to take this framework and deploy it quickly and easily has a great number of benefits to organizations of all types. So with that, I'm going to switch over to a demonstration so you can see how this works in action. All right, here we are at the Ordr dashboard. Now, the first thing I want to state about this dashboard is that everything that you're seeing here on this first screen is produced automatically. This is part of the integrations that we have with pulling information in from many systems that you already have within your organization, whether it be your switch infrastructure, your configuration management systems, your IP asset management, EDR, and other systems with agents. We're able to pull all of this together, run a tremendous amount of analysis on it, correlate this information together, and provide all of the visibility you're going to be able to see here. We do take it one step further, though. If desired, we can deploy sensors within a network as well to not just get the integration information from devices which are already known, but we can also see all of the network devices that you don't know about. The Amazon Alexa that somebody plugs into the network, the device that was never added to your EDR, but perhaps should be. All of these devices transmit information over the network, which we'll be able to collect. We'll run deep packet inspection on it, and we'll be able to then light up this information here, giving you new visibility into devices you never even knew you had. So here are some examples of that. So obviously, we'll tell you the total number of devices that we find, and we start breaking it up into very easy to understand categories up here on the top. We'll get back to the device risk information in a moment, but I want to focus you in on this device analysis. We create a hierarchy of devices based on all of the information that we find about the device. We correlate it into a data lake, and we're able to tell you, for example, for your physical security devices, they may be security cameras, they may be DVRs. All of this information here, when you click on it, we bring you to a list of what all of those devices are that we discover. We allow you to take a look at what the devices are. Very important if you're going to send somebody out to run a patch on a device. Again, we're discovering up here from integrations about who supports this, what's its business function, or this information that we discover off of the network. It's a network camera. We know the manufacturer. We're able to pull the model information, the serial number, the operating system, all of this granular context about the device. We're getting in real time all the time. And again, we can feed that into your existing configuration management system, or we can allow you to access it in here. We're telling you all of the network context. Where is it connected? Is it wired? And if so, to which switch port? Is it wireless? What's its SSID? Again, we're providing this detailed classification. So we're able to show you and allow you to manage all of your physical security devices together or just the specific groups of cameras. And we're also doing a deep dive on risk associated with the device with this multi-factor risk analysis, which I'll dive into in just a moment. So if I come back to this screen here about these devices, notice that I can pivot back to our main screen here, and you can see that within the group of physical security devices, we have all of these subcategories. Again, this allows you to get granular information about the information that you care about. Now, filtering, searching, finding information, obviously important, but we bring a tremendous amount of information right to your fingertips. Do you need to know how many of the devices on your network are still running Windows XP or other outdated operating systems? In this network, we have 858 of them. They're still running some version of Windows XP, probably embedded along printers and other devices. What devices have been discovered in the last 24 hours, maybe that haven't gone through your change control process, which haven't been seen in a period of time that may be an indication of loss or theft? We're also, of course, through various means, able to pull in information about business information. So perhaps you only want to see devices that are focused on your industrial development centers, and those can be pulled up right away. Now this goes to an important point. We're collecting information across your entire organization. What different constituencies care about are often different. So we provide a number of tools. Number one, we allow you to do a complete, what we call a data shaper. If I, for example, only care about devices because perhaps I'm focused on supporting devices that are in the Midwest, and the devices that I really care about are the facility devices, industrial devices, and physical security cameras that are within this is the purview that I care about, I can simply apply this filter. We call it a data shaper. And now, not just this screen, but the entire platform shifts to only show you those devices that you care about. So those same analyses that I was running before with the 800 devices around Windows XP, now I know that for my world, I care about these 25. Notice there are all these Siemens building management devices, and so this set of devices clearly needs an upgrade in order to get this unsupported operating system back off my network. Now, that's one example. We also have a specific healthcare dashboard that's done specifically for healthcare technology management and bioengineering organizations because they care about different information than somebody who may care about IT, IoT, or OT devices. And so by changing the persona to what we call HTM, the whole system again gets reconfigured, so now these biomedical engineers can only see what they care about. Obviously, they're going to care about the medical devices specifically. We're identifying information, devices that have protected health information, FDA advisories, and so forth. So again, a very specific persona for folks that care really about those medical devices. I'm going to switch back to the main persona though. And as I mentioned before, it's not just about what devices you have, but it's also what the devices are doing on your network that is very important. So here I'm going to flip over to the Network tab. And we have another dashboard here, which is specifically for those network constituencies. What devices are on which subnet? Which are on which VLANs? Do I have those risky protocols that are being used so that if I know that there's a remote desktop protocol or remote login or perhaps telnet that is being transmitted across my network, that could be an indicator of compromise or even just a misconfigured device. But this allows you to do some really interesting things. As a network guy, do I have any operational technology devices that are on my guest network? Well, I can come over here and just take a look at groups, and I can see, well, in fact, why do I have medical devices on my guest network? These are likely to be misconfigured, possibly somebody just trying to get their job done, connected them to a network they knew was available, and so I may want to quickly come back here and put those onto the right network. So again, we're trying to give the right controls to the right people so that they can focus in on what they care about. So all of this, again, I want to go back to that see, know, secure and how this fits into the chasm space. These are all of your cyber assets, right? Seeing what they are, seeing what they're doing, and seeing that level of detail is critical. Next up is the security side. So again, what are the vulnerabilities that are associated with each of these devices? Since we're looking at the network traffic, we're able to see what are they connecting out to on the internet. And again, we can correlate those with all of these known malicious actors and destinations. We're able to look at internal communications, and we're able to then see whether any of the traffic that's on your network is correlating with known malware activity or signatures associated with exploits. I mentioned earlier about looking at that network traffic, correlating across device types, and this is where we're able to flag things like behavior violations. Which are the devices that are suddenly doing something new that they had never done before? We're also able to look at the known tools, techniques, and procedures from the latest security threats. And of course, known vulnerabilities are another key thing that you need to track. Which of my devices have CVEs associated with them that are known to be a risk score of 8 or higher? With a click, I'm able to identify that I have, as you can see, 66 of these alarms, which correlates to a certain number of devices, which can be immediately pulled back to here. So I now have 30 devices that correlate to those 66 high vulnerabilities, and I'm now able to start going through and remediating these as needed. So let's talk about that for a moment. I have these devices. I have looked at my burn down lists. Like I say, we're looking at these. Let me take a look at these 10 high-risk devices here. This is a blended security risk. Now I take a look at these security cameras here. You can see that when I look at this risk score, we're looking at internal communication external communication, what it's connecting to out on the internet. We're looking at the vulnerability scores of those known CVEs against it. And we allow you to adjust the priority of each of these signals and how that turns into an aggregated risk score. We can then affect that risk score by the business criticality, which you can set so that, for example, a network camera may only be a level 3, not particularly important, but something like a PLC that's running an industrial process or a blood analyzer in a medical facility may be a level 5. That will adjust the risk score. So in short, you're able to get a prioritized list of just the things that you care about based on your business. And now we're getting into that third step. We talked about see, we talked about know, and now how do I secure these devices? Well, if I take a look at my actions here, these 2 security cameras, well, maybe I just want to take these off my network, right? These things are exploited, and in fact, if I take a look, I can even look at these security incidents. It has malware activity, it's connecting to a malicious URL, it's reaching out to a prohibited IP address. On top of that, I have a list of specific vulnerabilities that I need to take this thing off, I need to patch it, I need to do some serious work here. So great. First thing I'm going to do is I'm just going to add this to a block list. I'm going to shut these things down with a switch. 2 clicks to select my cameras, click apply. Now those things are off my network for future remediation. Well, I also see on here that I've got a couple of desktops. Again, I can't kick these things off. I need to figure out what's going on these devices. And we give you all of that information, again, around the security incidents. We're able to tell you who's logged into that device. We're able to tell you which software is on the device and which patches have been run. So with all of this visibility, though, you may still want to run it on your incident response process. Fantastic. Change VLAN, click a couple of buttons here, select the devices that you want to have VLAN, punch in the quarantine VLAN number, boom. We send the ACLs over to the switch, or we coordinate with network access control. Those things move over, and now you can sandbox them or run whatever tools you need to take those to the next step. Now, that being said, there are devices that you really can't take off the network, and you really want to have proactive control over those devices. So I'm going to take a look at this MRI here. And you can see that it's a Cigna MRI. Now, on our network, we actually have 2 of these devices. And when we look at these devices, we're not just risk scoring the device themselves, we're actually risk scoring every single connection that those devices make. And in doing so, and by looking at the connections and the network flows across all of those devices, we're able to identify which of those flows are normal for those devices and which of those are abnormal. So we have just identified these baseline flows here for these 2 devices. And you notice that there's a bunch of devices, a bunch of network flows here that aren't baselined. This may be the malicious communication that we saw on that other device. We're able to then add those to security policies and generate those types of zero trust or segmentation controls to say, great, I just want these MRIs to only communicate to these known devices on my network and nothing else. And in doing so, you're now able to send that policy over to your firewall so they can't communicate out to the wrong place on the internet. Send those over to your switch or to NAC to control that east-west traffic. And we'll do that via APIs to minimize the amount of time and effort your network engineering team needs to implement those. We can also provide the underlying command line interface, so all of that can be reviewed and controlled. That gives you that zero trust or least privilege management ability for all kinds of sets of devices, right? These kinds of business critical devices that you want to protect proactively. You can even group devices together by location, by characteristic, by business ownership, because we understand that multiple devices operating together are at the heart of many business processes. So all of those devices together can be identified as a single set of flows, a single policy that can be enforced. So I've spent a lot of time talking about individual devices, about groups of devices and how they can be managed together. But I want to take it up one more level to what we call a traffic analysis view. And this is really interesting because you want to be able to look at the top down of your entire network. And this really gives you that, we call it cyber asset attack surface management, right? Well, this is your attack surface. This inner ring here, this middle ring, these are all the device types that we discovered, we showed on that dashboard. The inner ring are all of your internal connections, your internal networks, your IP addresses, your DNS servers, and so forth. And the outer ring, those are all that's the internet connections. These are all customizable. We've customized them to show tools, techniques, procedures for known exploits like our evil, dark side, log4j. This allows you to look very quickly and say, what are my industrial devices doing? Well, I have some of them that are talking to prohibited countries. I have some of them that are going to malicious URLs. And we're able to then let you pivot back and forth between these and say, well, what devices are going to malicious URLs? Aha, it's this laser screen control panel. And I can come right here, take a look at that device. I can see the security incidents. I can see the vulnerabilities. And in fact, I can take actions right there as well. We're able to then come back and pivot back around and say, well, what else is going to malicious URLs? Well, I have a lot of different things in my network connecting to those. I can come in and say, well, I'm a network guy and I care about the air-gapped networks on my industrial devices. Well, we're able to look at this VLAN view and allow you to take a look from a VLAN perspective. If this is my industrial VLAN, why do I have some of them connecting out to the internet? I have cross VLAN communication, and I have this VLAN communicating to internal addresses as well. This may indicate a need to take care of those segmentation rules, start automating those firewall rules, and implement stronger controls between the different devices within my environment. And that's really at the heart of Chasm, right? Being able to look at my devices, understand how they're all interacting with the world around them, and rapidly be able to come in and take action against them. So with that, I'm going to go back to a quick slide because there's often a question of how do we do what we do, and I'll take you through the architecture. So here's a quick slide on how Ordr works. Step one is a collection step. We will pull information in from a large number of API integrations that we have, pulling information in from your switches, from your ServiceNow, from CrowdStrike, from Infoblox, from Active Directory, from VMware, from AWS, on and on to give you full cloud-to-ground visibility by pulling in all of the information from the devices that you know about. We also have the ability to read the network traffic by connecting into a switch port, span or tap port. So we're taking a copy of the network traffic and running deep packet analysis on it. So if a device doesn't have APIs, if it doesn't have a management system, we can still see that device. We'll also be able to read NetFlow coming over your network from remote locations. We'll be able to extract metadata from different network connections, and again, pulling in that rich context. All of that goes into our data lake. This sits up in the cloud. It's a massive scalable database, which then correlates all of the information that we're seeing from the network traffic, from all of the API integrations, and it matches it to the database of millions of devices that we've already seen from all of our other customers. This is also where we correlate the information from public databases of CVEs, manufacturing databases, FDA feeds, vulnerability information from URL filtering and threat feeds. All of that is correlated in our data lake and is then used to create those risk scores, the analysis of the network flows, and then that's then pushed into the policy enforcement actions that we have with the firewall, NAC, switches, etc. We also are able to have all of the information, all of that correlated information pushed up into a SIM or a SOAR, into your ServiceNow system for configuration. We're able to pull information in from your VMware to see workloads that are virtualized, or AWS to see what's going on in the cloud. We're able to push information up into vulnerability management systems to coordinate scans so you're not scanning devices which can be knocked over by an active probe. So all of these integrations tie together in both our ability to retrieve the information as well as push information, augment those devices and those systems with all of that context that we're providing. So again, when you think of Chasm, often the focus is on how are you pulling the information together in order to get the view of your environment, that attack surface, if you will. We really think about it in two other ways. One is, how can we take the data we collect and make all of those other systems better? And then how can we also use that network intelligence to find the information that's not in your management systems already, that aren't available on an API? And so those are some of the real differentiators that we have as an organization. Thank you for your time. For more information, please reach out to us. You can visit us at our website, and we'd be happy to do another demo for you. And ultimately, we can do a proof of concept right on your site so you can see how we operate within your environment. Thanks and have a great day.